All right, let me see your screen. Let's see what you have.
Okay, let me share. So I got prepared and I set up. So I did vary a little bit. I set up a GPIO. I did set up a different LED, which was A15. So there's a slight deviation, which is fine. I'll make the adjustment in code.
Okay,
PB0.
So why don't we start by configuring your USB port so you can have output to your computer? Okay?
That'd be great.
All right, so go click on the A to Z tab on the left top. All right, and go to your system. I mean RCC. So we're gonna set your clock source and set the high speed to external. Yeah, that was fine. The crystal ceramic resonator. All right, now scroll all the way to the bottom on the left pane and go enable the USB OTG FS. Not sure what that means, but go ahead and enable the device only. It's when you click it, there's options that pop up on the next pane. There you go, device only.
Weird.
Okay, so it's not letting you because you enable some other pin somewhere else. So go disable UART6, USART6.
Reset state?
Yeah, on both. All right. So now go back and enable that one.
Device only. Yep.
Yes.
No?
Now you have a USB device option available on the left pane.
I see.
Left pane. Bottom.
Yes.
All right. And go ahead and enable that one for the third option, communication device class, virtual COM port. Okay. So that is it, except that now your clock has an error. If you look at the top on the clock configuration, there's an X.
Yeah.
Click on that one. All right, click yes. So I'm gonna try to find a configuration that matches the megahertz for the. I can't read your screen. The resolution is not
Should I
good.
hit resolve clock issues?
Yeah.
Okay.
All right, so that's it. So now go back to the pinout configuration. So that should give you data for outputting to your computer. So let's go and test that. So generate the code.
Oh, okay. So you don't want to mess with UART6 yet, or no?
No, we're not doing anything to it. It's disabled. We're using USB.
Okay.
So so when you enable USB, it takes over the port for USART6, right? So it becomes disabled. It's no longer accessible.
Understood. Yep.
Okay, so if you look on the left, it added a folder called USB underscore device.
It did.
Yep. So expand that one, expand the app, and see where it says, well, I can't read it, but it's the fourth one from the top. The H file, the next one, the fourth, that one.
Yep.
So you're gonna copy, or you're gonna include that into your main.c file.
Okay.
So go on line, I believe it's 25 on your C file. It's already open.
Oh, yep. Uh-huh.
Right, so just do an include and add that file.
BDCDC IFH.
Yeah, something like that. That one.
Okay.
All right, so now go all the way to your loop. So scroll down to the loop. And you already passed it. There you go. There's your loop. All right, so inside the loop, just put a delay of, let's say, 1 second. So
Yep.
okay, 1000.
Yep. Got it.
And then you're going to use a function that comes with the USB library. It's called CDC underscore transmit underscore FS. I believe that's the name.
Okay. But before this, or
Anywhere, it doesn't matter.
in the while loop or outside the while loop?
Inside the loop. We're going to be
Okay.
sending data.
So you said CDC?
Right, underscore transmit, that one, the first one.
Yep. Mm-hmm.
Okay, and so you're going to include a buffer. We don't have the buffer yet, so just give it a name. It's called a buffer, it doesn't matter. And then the length of the buffer, so use the string function str length to find the length of that whatever you're sending. Okay.
Oops, sorry. Yep.
All right, so declare that buffer before the loop.
UN8?
Yeah, 8 bits. And don't put a size on it, just declare it as an array and put a value on it and put a terminating with a control return and a line feed.
Okay, so I'm sorry. So did you want something else in here, or
No, I think we're going to do it a little bit different. So let me share the screen and then you catch up to me as I explain how it's done, because it's a little difficult navigating stuff. I can't read your screen. And
hold on. What if I do this? Hold on.
No. The other thing is that you still don't know when I'm talking about a left pane, top pane, a tab, or anything like that. So that it's cumbersome. So let me share my screen.
Go ahead.
All right. Let's see. All right. So that's my setup, right? You can see it.
Yep. Uh-huh.
All right. So you can see when I press the button, it leaves it on, leaves it off.
Yep.
All right. So we're gonna do that whole setup.
Yep.
Here's my USB connected to UART one. Here's my wire connected to this little potentiometer, and then here's on bit 0 is connected to that button right there.
Yep.
Right?
Uh-huh. Yeah.
Okay. So we're gonna do a brand new setup with it. So we're gonna start from scratch. So we're just gonna close that and open. Just close this thing. Start a new project.
Give me 1 second. You can just go ahead. I'll be quick. Yep. Back.
All right. So I'm creating the project and naming it interrupt demo.
Yep.
Okay, so first thing I'm gonna do is I'm gonna pre-assign my pins uh, for my ST link, so I don't forget that they're already taken. So those are my 2 pins. I'm gonna go and set up my clock. to use the external clock, and that enables me this option here to enable USB on this processor. So I'll go with device only, and that will enable this and disable this UART.
Yep.
Right? So I'm gonna enable the virtual COM port, and I'm gonna leave the settings the way they are. I'm not changing anything. So the only requirement is that the clock needs to be configured correctly, right? So there's an issue here with the way the clock is set up. I don't really care how it needs to set up. I'm just gonna click on resolve clock issues.
So I missed that first step with the RCC. Should I go back in and change my?
No, we're gonna do this whole thing here. It's gonna stay on the video, and then you can go back and review it.
Okay, cool.
All right, so so it's done. We have that.
Yeah.
Right. So we're not gonna do anything else right now. We're just gonna test the USB port. Right. So we'll generate the code.
Yep.
And it's gonna end up adding. What is this one here? Is gonna end up adding a couple of new folders here. And if we did it correctly, we'll end up with the USB device folder, which is right here. So let me close this once. So let's make it clear. And I'll open that one. So here.
I have a question real quick.
What's the question?
So with the FTDI, with the other processor, because that was a physical device, I didn't have to go through all this setup. But because I'm using the actual because I'm actually using the USB here, this is the configuration necessary.
Yes.
Okay, got it.
On the other one, it's not USB, it's serial communication.
Understood.
What's the name of it? I believe that's the name. Yeah. So then I'll go to my loop, and before my loop, I'll define a buffer. And it'll be an array, and I'll just have USB data. Here, I'll add a delay of 1 second, and then use the CDC transmit. That's not what I wanted. CDC, that one. I'll use my buffer. And the length of the buffer.
Right, makes sense.
Right, so I'll send it to my unit. Okay, so this comes up automatically the first time you program your project. So I'll use ST-Link, scan for the one connected, say okay, you're going to continue with the process, it's going to send it over. And so we're going to use this. It popped up on the other screen, but here's the data coming across, right? So it is working.
Yep.
It's using COM port 5. So if I go see here, it has my new COM port, and it was already selected because I've been playing with it today. So, so that works. So the next step is to we'll do an interrupt, right? So we're gonna test the so we're gonna test this push button right here.
Yep.
This one, right? So when I press it, if I press it, the LED here is gonna come on, or it's gonna go off. So it's gonna toggle on and off. All right.
Meanwhile, the USB will continue to fire, right?
Yeah, I'm just gonna as I write code, it's just gonna continue to do its own thing.
Yep. Got it.
This is gonna be interrupt driven, so it doesn't matter what's running, right? It should kick in. right? So I have the button on PV0 right here. So I'm gonna enable the interrupt, this one here, interrupt 0. And now if I go to my GPIO, I can give it a name. Well, I'll give it a name here. So let me move this up. And I'll call it button. Okay. And by selecting it here, I can say, well, what do I want to detect? Well, I'm going to be detecting the falling edge. Because the way I have it connected, it's connected to voltage through a resistor. So when I drive it to ground, this interrupt is going to fire. So I'm setting the mode, and then I have to go and set the interrupt to enable the interrupt.
That makes sense. I'm tracking.
Okay. I'm also going to enable the onboard LED, which is this one. I'm just going to set it as an output. And I'm going to name it, call it board LED. Okay. So let me generate my code.
Yeah, I'm tracking everything. I'm not lost. It actually makes sense.
All right. So now that I added interrupts for GPIO in my library, I should have other stuff here. If I go to GPIO, and I'll do a search for IRQ, right? So this is my IRQ handler, and then it's calling this function right here, or this one, I should say. Right, so I'm going to use this function. I'm going to redefine it in my C file. So I'm just going to go just above the main under this section, under code 0. I'm going to put it there, right? And what I'm going to do is, because you're likely going to have multiple interrupts, you want to check to see which one's firing. So I'm going to check the pin if it's equals to my board pin, that one. And if it is, then that's the one I'm looking for, right? So then I can toggle my onboard LED.
Right.
So that should be enough.
And you don't need any debouncing because we have it tied to a resistor.
Right. Well, yeah, it's if you will have to debounce it either by software or by hardware, right? But this is just a demo; it doesn't really matter.
Right.
Right. So when it's finished loading, it's gonna come up here. All right, it finished. So you can see it's by default is on. It's likely because of the way it's set up. So if I press it, nothing's happening. Why is that? All right. Let's see. For LED port, for LED pin. Oh, okay. This is not the right pin I should be checking for. The other one is named button. Remember?
Yep.
Yeah, I named it button, right? So the interrupt is assigned to this pin and is named button. So button underscore pin.
Yep.
All right, so let's compile again. And we'll bring this up. Let me make a little bit smaller. Right, open up on the other screen again. So there's my data coming across, right? And if I press the button, you see the LED.
Wonderful.
Comes off, comes on, right? So, all right. So next step would be to enable the UART, right? So we're gonna enable.
You mean the CAN? Or I'm sorry, the CAN, the ADC.
No, the UART.
Okay.
So the next thing we're gonna enable is this guy right here, this one. So we're gonna connect to serial communication to that device.
Okay.
All right, so that one is connected to, let's see,
What is that device, by the way? Is it just a
that's an HM11.
Wi-Fi? HM11, got it.
Yeah,
Yep.
HM11 Bluetooth device. So I'm
Yep.
gonna go
Okay.
to the pictures I sent you earlier,
Mhm.
right? So here it is.
Yep.
So it will be connected to B6, 7, 8, and 9. So
Got
this
it.
will be transmitting on the from this device, transmitting, receiving voltage ground. So I'm gonna
Great.
set this one to high, this one to low to provide voltage to this, so I don't have to connect it to anything else, no wires.
Got it. Mhm.
Right, so we'll go back to what is it? Right here, and that would be UART 1. So we're gonna enable that one, asynchronous. We're gonna change the baud rate to 9600. That is the default configuration of that device. And if you look, it put it on PA10 and PA9, but we want it here, right? So I'm gonna hold the control key on my keyboard, click on one of the buttons, and then it'll blink the other one where it can be enabled. So I have that one, and I'll move this one, right? And we said 8 and 9, we're gonna use them as ground and voltage,
Yep.
right? And if we go back to the pictures, right here, you can see that is first is ground, then voltage, right?
Yep.
All right, so I'll go to my GPIO, and my PV9 should be ground, it's already pulled low, and my PV8 should be high to give it voltage.
Got it.
Right, so that should be enough. And
Oh, so you remapped ground and 3.3 and ground. Okay. Yeah.
yeah, this is just so I don't have to put jumper wires to give it power and ground.
Yep.
I'm just gonna let the
Got it.
processor handle it.
Yep.
Right, so I'm gonna go ahead and configure it, even though right now it's still not gonna do anything. So let me finish the configuration. So we have UART, right? So we have all of that, and we're gonna be using interrupts. So I'm gonna enable the interrupt as well, right? On our NVIC settings for
Yep.
the
Yep.
UART, right? So I will generate the code. All right, and without adding any additional code, I'm just gonna send it to my device to see if the pins are configured correctly. So if they are,
Mhm.
you're gonna see the blue light flash,
Yep.
which means it's gonna have power, the correct settings.
Right.
All right, so there's the blue light. It's blinking, so we're good to go. So now we can start adding some code to this. So the first thing we want to do is we want two functions, two interrupts. So we want one that's going to let us know when it's done sending data and when it's done receiving data. So we should be able to find it on their drivers, the hall driver and then the source on their UART right here. So I'm going to do a search for callback. Well, it's pretty much any of this ones here, right? So I'm going to go search for that one.
Complete callback. Yep.
STMA. So here we go. So we're going to be using this function.
Yep.
This is when it's done transmitting data. So we'll put this one right here. We'll go back and get the other one. It should be this one.
And you have this to USART 1 or UART 1, right?
What do you
For
mean?
the Bluetooth. For the Bluetooth, is it mapped to UART 1?
Yes.
Okay. Yep.
All right. So this thing is connected to PV 8 and 7, right?
Yep.
And So PV, I mean 6 and 7 is UART 1 right here.
Yep.
Okay. So now I'm just moving the definition of the functions to the C file, to the main C file, so I can detect when data is sending, when data is sent and when data received. So we're gonna set up a flag just to let us know when it's done sending. We're only gonna use interrupt as a way to tell us, hey, it's done sending data. So we'll call it TX ring. We'll set it to 1 as a start, and then we're gonna set up a buffer to get data and also to send data. So let's see, we'll call this UART buffer, and then we'll give it 100. Actually, let's have a single buffer. So a C buffer, 1 character, gonna be defined as 0, and then we're gonna have a message just to be able to send it somewhere and we can see it, right? So we'll have a, let's just call it message buffer. We'll give it 100. Define it as empty. So now when we're done sending data, well, first we want to test to see if it's able to send data, and then we'll check to see if we can receive it, right? So the first thing is when we're done sending data, we want to set the TX rating flag equals 1. And then to send data, let's go to our loop. Where's the loop? Right here. So we're gonna copy some data to the message buffer. Message buffer. And we'll just call it UART data. And then we'll send it. UART transmit. We're gonna use the interrupt version. Underscore IT means interrupt, or interrupt version of the function. Then we'll use that buffer. We'll see what the length is of message buffer, and okay, before we send it, we are going to check if TX rating is set to 1, and if it is, then we'll send data, and then we'll set it to 0. So we can't send another one until it's done sending data. So I'm gonna go ahead and compile. And I am going to send it to the device. And let's see. Oh, hold on. Let me enable my Bluetooth on my phone. Let's see if it'll let me join now. Hold on, let me kill an application here. It's keeping me from connecting. All right, so it's not gonna let me connect, so let me just show it through the camera so you can see what it's doing. So you can see this is sending the data across, right? So I'm capturing the data on my phone.
Yep.
Right, so we know UART can send data, so now we have to check to see if it can receive it.
Right.
So for that, we are going to, so we're gonna have it where we're gonna queue the interrupt for X number of characters, and when it receives that many characters, then it's gonna fire, and we'll be able to capture that data. So,
got it. Yep.
So we have to call it at least once outside of this to capture data. So we're gonna call it right here before the loop. And we have a buffer of C buffer, so we're going to use that one. We're going to capture one character at a time. It's going to be received using the interrupt as well. So the data will be C buffer and the size will be 1. So one character. When we receive one character, this interrupt is going to fire. So when it fires, we can call it again and just keep it in a loop. So every time the same interrupt will call itself, will keep queuing itself until we get all the data. Right? So when we get this data, what we can do is let's create another message, another buffer here, just for debugging purposes. So this will be our buffer, and let's just call it for, let's say 20. Doesn't really matter, it's just to capture one character at a time. Let's make it a little bigger. 50. And here, what we'll do is we'll capture the buffer, we'll capture the data, put it in our buffer, and we'll call it, received. Yep. And this will be the C buffer. Okay. And once we receive it, we'll send it. We are going to send it to the COM port, CDC transmitting FX. So this is USB communications, right? Okay. So we're going to send this our buffer, and the length our buffer. All right, so let's see what this does. All right, we'll take care of the warnings later. That's an issue. Let me compile it. We close this. Yep. All right, so let me also bring this here. Try to move it out of the way. So when I press any of those buttons, the wire's getting on this way, but when I press any of those buttons, it's gonna come out here. So you can see the data coming across. Yep. Right? Wonderful. And I'm also seeing it here on the phone that it's also sending data to that one as well.
Right. Okay. Right? Wonderful.
So,
great.
So now the next step would be the ADC, right?
Right.
All right. So
and that could be just something as simple as drawing it to the 3 volt, just to keep it simple for you.
Yeah. So so now let me go bring up a picture. So the ADC is connected to A5, right? So right here.
I see. Yep.
Right, so let's go set that configuration right here. We're going to use ADC. It's on channel 5.
Yep.
And if you notice now it's green, so you enabled it. Channel 5 right there.
Yep.
Right, we're going to go and see if there's any settings we need to set. Scan conversion mode.
And you'll need NVEC, right? Or NVEC.
Continuous conversion, DMA, and scan conversion mode. I think that's the only one.
Do you want it? Do you want a continuous conversion or no?
No, I want to have
Okay.
full control over when it's going to convert.
Got it.
And you'll see why,
Got it.
right?
Uh-huh.
So I have my settings. Now I'm going to go enable my interrupt.
Yep.
Right, so that's all I need.
Mm-hmm.
And let's generate a code. Okay, so I think it generated the code. I'm not sure why it didn't switch. Then click on it again. Might be because I have video running, recording, and everything together. So
Right.
let me just generate this, and we're gonna get the definition of the callback for the interrupt for ADC.
Right.
So we'll go again to drivers under this branch. We're gonna find the ADC right here.
Mm-hmm.
And again, we'll go search for callback. And obviously, actually, it would be easier to find it on the header file, but that's okay. So let's see, where is that? So this is the one we want, but that's not the actual function name. It has something else. It's prefix here, this one here. So that's the one we want. All right. Takes me to the right definition, so here it is. We'll copy this to C file, and then we'll go to actually let's put it down here. All right, so this one is going to generate whenever we queue the interrupt, and once we queue it, we can go and read the data. So what we're gonna do here is when this fires, we're gonna go capture data. So we're gonna use that buffer, that same buffer, to use it here. So I guess we can copy this, move it here, and say ADC interrupted, and then put out the value here. So the value is going to show. And get value of this ADC. That should do it. And then we'll send the buffer, and it's going to display that information when it fires, right? When we get data. Okay, so now let's make it so this fires, this interrupt becomes enabled when you press the button. So only when you press the button, right? So then we can say how ADC is a start conversion, I think. Yeah, so start and that one. Right, so that's all it's going to do. It's going to start a conversion, and then when it's done, it's going to come here. Now you have to remember that when you specify multiple channels and you go and read those multiple channels, depending on how you want to read it, or you use DMA, which is a lot easier, and then you'll have more control over those channels. In this instance, we're just going to do this. So this should be enough.
Right. Yep.
Right. So it's going to, when we do this, it's going to do two things. One is going to either turn on the LED or it's going to turn it off. So it's going to toggle it. And we're also going to see data on the output of this guy right here.
Got it.
All right, so let me compile. Right, no errors. Run it. Well, that finishes. Let me bring this up. All right. you'll see once it's ready, you'll see this start getting data here on the phone.
Right. Yeah.
All right, so there's the data. Now I can go here, bring this guy up. Okay. So when I press that button, it gives me data,
Yep.
right? So
Yep.
if I turn the knob, it should give me a different value when I press the button.
Yep.
If I will go all the way up, it should be the maximum. We have 12 bits of resolution, so that's 4,000
right.
values. If we go all the way to the bottom, it gives us 3.
Perfect. So question, you're going to upload this video to your YouTube, or where are you going to upload this?
Yeah, it's going to be on YouTube.
Okay.
So that's the end of the video.
And then,
so let me hold
and
on.
then
So let me cut the
are you
video
gonna put,
and then we'll continue talking.